this is Jan. I'm here demonstrating the circuit design that I created with Salomon for ECE 2001W class. So let's start. This is the transmitter circuit. It's fairly big. We start here with the microphone circuit, which is a power source. This says 4.5 volts coming through a resistor into the mic, and then the output of the mic going through a 1 microfarad capacitor, which then comes through into this op amp, which equalizes it, which sends an output through another capacitor and a resistor here into the summing circuit. And on the music side of it, we have the music coming through this is the music cable coming through that cable into a 1 microfarad capacitor, through another resistor, through another op amp, and this gain is about, I think it was 3 times gain, and this gain up here for the mic circuit was about 100 times gain. And both of these come together into the final op amp, which sums the 2 signals together and sends an output through a laser. So now we're going to go over the circuit diagram for our transmitter circuit, starting with this iPod section right here. The iPod is going to release an AC signal, right, which goes through this 1 microfarad capacitor, going through another resistor, a 384 ohm resistor, and then a 2 kilo ohm resistor, that which produces about a 6 times gain for the voltage. And then we offset that gain, we offset it by 4.5 volts. And then after that signal comes out, it goes through this in total is our summing part of the circuit, which we'll go over after. So then we go to the microphone part. The microphone also goes through a 1 microfarad capacitor, but then it goes through a 430 ohm resistor and a 43 kilo ohm resistor, which produces at 100 times gain about. And the reason the gain is so high is because the microphone produces really low voltage and can't release a really good signal at all. So we had the op amp bump it up 100 times, and again there's a 4.5 volt offset, which we'll go over later. So in the summing part, both of these produce about the same voltage. So then when we sum them together, these capacitors are there to make sure that no DC current comes through, and only the AC signals will come through. These resistors there make sure current still flows through it. And then we come here to the final op amp, which produces another 4.5 offset on the op amp. This is our summing op amp. It sums the 2 signals together and pushes it out. And then this all together here is our bias T. The bias T makes sure that no DC current will flow through at all, and only the no DC signal will flow through at all. Only the AC signal will flow through. So now we're going to go back to the 4.5 volt offset on these. The reason that that's there is because the laser works from a range from 4 volts to 5 volts, right? So any voltage that comes in that range, the laser will shine. If not, the laser won't. And the reason there's a 4.5 volt offset is because if we didn't have it there, this signal would oscillate around 0 volts, so between 1 and -1. But the laser will not take the -1 or 1 volt and shine. So we had to offset it to 4.5 volts, so then it oscillates between 4 and 5. This is our receiver circuit. It takes an input from the photocell, from the photoresistor to this capacitor here into an amplifier that was provided to us, which the gain was set, for the amplifier was set at 20, which outputs into a capacitor, which comes to the speaker, which is here. So this is a circuit diagram for the receiver circuit. It starts with this photoresistor, pushes the signal from the laser through this audio amplifier, which was given to us so kindly by our lab TAs. This audio amplifier is defaulted to 20 times gain. It's defaulted to 20 times gain, so that's what we kept it at, and then pushes it out to the speaker through to a 250 microfarad capacitor. Okay, so right now we have a demo. We're going to do a demo of the circuit. Right now, this transmitter is connected to a YouTube video through my iPad playing "Ima Boss" by Meek Mill, and we're going to shine the laser at it, at the receiver. Hold on. And as you can hear, and theoretically, as long as the laser can hit the photoresistor, this could go as long as possible. I can transmit this signal from 50 feet away as long as the laser can reach it. You can clearly hear its audible music. So yeah.